Right now we have a great talk by Shah and Michael. We have Insecurity through Censorship, Vulnerabilities caused by the Great Firewall. Let's welcome them to the stage.
Thanks, Silvio. So we're going to be talking about insecurity through censorship, which is talking about some vulnerabilities and some interesting behavior and vulnerabilities that we found with the Great Firewall of China. For those who don't know us, we're the co-founders of AssetNote, tax surface management company here in Australia. But let's get into the juicy stuff.
Thanks, Mike. Yeah, so for us to actually understand what's going on with all of this, we're going to have to go a little bit into how DNS works generally. But for the first section, we're going to really just talk about how we discovered this DNS poisoning in the first place. Thinking about DNS, you have really 4 types of servers. You've got the root name servers, which have a static list of IPs. They tell us what the TLD name servers are. From there, the TLD name servers tell us what the authoritative name servers are, and the recursive DNS servers are actually just reaching out to the authoritative name servers. So this is like a very simplified explanation of how DNS works, but this is kind of the hierarchy that you should be thinking about it in. But we're mostly going to be talking about the authoritative name servers today. So if we take a look at what really happens in the life cycle of a DNS query, you've got your computer, which reaches out to the recursive resolver, the DNS resolver. That then reaches out to the root server, which then gives us the address of the TLD server, and the TLD server gives us the address of the authoritative server, and finally, the authoritative server gives us the address of the website, or whatever record type it resolves to. What we're going to be talking about today is actually something that affects the authoritative server. So DNS poisoned here. And if you remember the Snowden leaks, there was a situation where Google's traffic was being intercepted and the SSL traffic was being removed. That's where they had this snarky little comment, SSL added and removed here. In this case, China is poisoning the authoritative name servers. So I guess maybe the first question is, how did we come across this? Well, it was 2021, and we started noticing that there was a lot of domains with the .cn suffix that were returning really bizarre results. Initially our minds jumped to the fact that maybe this is just because of unreliable DNS resolutions, and we suspected that maybe the resolvers themselves were not responding consistently to our requests. We asked ourselves, is this something that is just due to inconsistent DNS load balancing, or is this a problem with the resolver? But given that we do hundreds of millions of resolutions a day, we didn't really initially conclude that this issue was as widespread as it was. We initially just built some logic to filter out some of these error-erroneous resolutions, but we started thinking, is there something more nefarious going on here? As time went on, we saw these odd DNS resolution behavior on more and more domains, some that didn't even have the .cn suffix. These DNS resolutions were all leading back to seemingly random IP addresses, which kind of perplexed us even more. We started investigating this, and we found that these random IPs were coming really from the authoritative name servers. But we asked ourselves, did this issue affect anything more than .cn suffix, and what was the common thread here? What led to this DNS poisoning that we were seeing? So we started debugging this. We started looking at the responses coming back from some of these resolutions, just to see exactly where this was coming from. We started asking ourselves, is this with the recursive resolver or the authoritative resolver? And we can see that as we walked the resolution tree, the fully qualified domain name delegated its name servers to alibabadns.com. So you can see here that this specific DNS record returned an IP address, and that was being served by ns2.alibabadns.com. We tried to do multiple different resolutions to see how consistent this was, and it turns out that it was pretty consistent. Just doing 10 resolutions, almost half of them were returning IP addresses that were unexpected. But yeah, this was really unreliable, unstable DNS resolution, but it was definitely some level of poisoning going on. And yeah, we started digging a bit deeper, trying to create a minimally reproducible example. We managed to distill it down to any DNS query, specifically including the word webproxy.id. Later, we found out there's actually a really large list of keywords that leads to this DNS poisoning. But you can see here we've done, we're just doing the dig command with webproxy.id and the domain and pointing to ns2.alibabadns.com, and we're seeing that a lot of these records returned seemingly are poisoned in some respect. But yeah, we also suspected that this was isolated to a single DNS resolver. We thought that, okay, this might just be Alibaba or something like that. But we actually found that this was affecting a lot more than we initially thought. And even Cloudflare, which is a company that seemingly thinks of security in high respects, was also vulnerable to the same DNS poisoning attack. So yeah, even with Cloudflare, you still get your DNS queries poisoned. And yeah, we could confirm that these keywords were actually the reason that this poisoning was taking place, because we tried to get records back for we proxy versus web proxy, and we would see that only when webproxy.id was inside the subdomain, we would actually get these poisoned records returned. So this is just an example where we've done that resolution to show the difference between when the keyword is present and when it's not present. And coming back to the original question, was this an issue with the recursive resolver or the authoritative resolver? Well, not really either, but something's really fishy at the authoritative name server level itself. If we attempt to even resolve an entirely made-up domain against Cloudflare's resolvers with one of the keywords that we found leads to the poisoning, we still get a response, which means that whatever's doing this filtering or poisoning is quite greedy, and it doesn't really matter if the domain even exists. So now that we've kind of identified that it's the authoritative name servers that is being poisoned, the responses from them, we wanted to understand what IPs is it resolving to? Like, is there a pattern in these IPs? What exactly is triggering this poisoning? And like, what is actually going on here, really? Well, we found that there's actually a large list of keywords that trigger this poisoning. And you can see some of these keywords here. And you can start noticing a little bit of a pattern. A lot of these keywords seem to be, somewhat related to what you'd expect to be censored inside China. We have a full list of the DNS poisoning keywords as well on our blog, but we worked with another researcher, Eric, who had come across this issue independently as well, and he also shared a list of keywords he had identified that leads to this poisoning. And then the question about what IPs do these resolve to? Well, actually, it's a huge list of networks. Over here, you can see obviously some really large networks like Cloudflare, Twitter, and Dropbox, but really it was a very diverse set of IPs. And all of these IPs, the diversity here is actually one of the reasons why this issue is readily exploitable in many ways as well. So what we learned from all of this is that we confirmed that any domain that is using a name server hosted inside China was susceptible to DNS poisoning happening within China before it reaches the rest of the world. From our rough statistics, there's approximately 30 million domains alone in the CCTLD. And this issue is a bit more widespread than that, because actually you can have name servers hosted in China without having the .cn CCTLD. So it may exceed that number. And it doesn't matter if you use Alibaba or Cloudflare or any of the other providers. As long as the name servers are actually hosted in China, the DNS responses are being poisoned. So naturally, what we thought, coming from an offensive security background, is what can we do from an offensive security perspective now that we have this information? So the next section, I'm going to be talking a little bit about how we exploited the client side now knowing that we have DNS poisoning on 30 million domains. The first concept is really just taking advantage of the sinkholes. We know that from our investigation there's a number of different networks that these users are sinkholed to, and this is a really diverse set of networks, many being CDNs like Fastly or hosting providers, and others being outright odd like Twitter and Meta. But we discovered that we could take advantage of these networks these DNS records point to in order to host our own arbitrary content on any vulnerable domain. This means that we can perform client-side attacks on the 30 million domains I mentioned, and we're going to discuss two specific attack vectors with POCs to exploit this relationship. So the first thing is going through how Fastly works. Fastly is a CDN. If you point a subdomain to Fastly but you don't register it inside Fastly, you get this neat error message that just tells us that this domain is not registered. So naturally, you can understand that if we're able to coerce any domain to go to a Fastly IP address, we may be able to just register it on Fastly and then serve our own content. This is pretty much perfect for our DNS poisoning attack, because we can serve arbitrary content for any subdomains that trigger the poisoning. So we first create a Fastly service, and we add our target/victim domain. In this case, I just added domain.cn. We add our server's IP address. And then we disable TLS to our host just for convenience to get this service up and running on Fastly. And then finally, we end up with an exploit that looks something like this. So you can see that domain.cn is actually loading content from our website. We could load anything we want, like an arbitrary script or whatever it may be. Now, this affects pretty much every .cn domain on the internet at the moment. So we're loading arbitrary content. It could be phishing pages, could be malicious content, could be, a script, could be something even more nefarious than that, such as stealing HTTP-only cookies, because you are using Fastly at the end of the day, and you are getting server-side processing in that case. So the Fastly exploit, how it works is that we create 1,000 random subdomains with the suffix, which has one of the keywords that is leading to the poisoning. And then we target whatever domain we want. In this case, we targeted domain.cn. We progressively load all of this inside image tags, and we let the browser handle the DNS resolution of all these different random subdomains. When an image is successfully loaded, the onload handler is triggered, and then the second stage of the exploit can take place. So we can then do whatever second stage we want, which may be loading a phishing page, maybe stealing cookies, whatever it may be. But I just want to note that even though the demo that I showed earlier was very visible, all of this can happen quite invisibly inside your browser. So this is the example code. I'll pause a little bit here, but you can see it's quite simple. It's just doing exactly as what I mentioned. It's pretty much generating those random subdomains, loading them up in a progressive manner, and using the onload handler to trigger the second stage of the exploit. All of this code is available on our blog post as well, so you can grab it there, and there's exploit code for both of our POCs there. So then that brings us to the second exploitation vector. What if we weren't able to register a domain on Fastly? Is there something else we can do? Well, our security research team in 2023, we discovered a reflected XSS in cPanel. We also published the POC back then. cPanel is probably one of the most popular web control panels out there to exist. It was actually created the year I was born. That's how old it is. And it is basically everywhere. So if we found a single IP that was running cPanel from the poisoned IP list and vulnerable to this XSS, we now have an XSS on the target/victim domain susceptible to the poisoning. So this is what this POC looks like. You just load it up, and it will progressively load cPanel images, and then you've got the XSS firing. Now, as I mentioned earlier, this affects 30 million domains. I know it's just an XSS, but the scale of this is quite extreme. So you can see the XSS firing multiple times across many random domains. Basically any .cn domain is vulnerable to this. So the cPanel exploit, the way it works is quite similar. We create 1,000 random subdomains with a specific prefix. One of those will resolve to a host running cPanel, and the image loader will confirm it, and then we do the second stage of the exploit, which is the XSS. Essentially, I think the biggest takeaway from this is that any XSS on any of the sinkhole domains or sinkhole IPs means you've got an XSS on your attack surface as well. The example code, again, is quite similar to the previous one and will also be available in our blog post as well. Now that we've gone through the two different exploitation vectors, I do want to spend a little bit of time talking about the limitations here. Even though that this is a very wide impacting issue, there are some major limitations. On the Fastly technique, we can capture HTTP-only cookies, as we can run server-side code that logs the cookie. But in the cPanel XSS technique, we can't do that because we're limited to what's accessible by the client side, and we can't access those HTTP-only cookies. Neither of these techniques can capture cookies that have got the secure flag, because we can't generate an SSL certificate on these poisoned subdomains. Maybe it wasn't clear earlier, but every time you resolve one of these poison subdomains, it returns a different IP address, which means that we can't just spin up SSL certificates for any of these poisoned subdomains quite easily. I'm sure it's possible, maybe a little bit of work and an exercise to the reader. But account takeover attacks are still possible if the secure flag is not used and the HTTP only flag is used, and you've got a Fastly exploit, or it's not used and you've got the cPanel exploit. For further attack vectors, I think there's definitely a lot of potential here. The sinkhole IPs are quite extensive. It's hundreds of networks. So more exploits with claiming CDN infrastructure seems likely. More XSS-related exploits also seems likely. Even though we've only really disclosed 2 exploitation vectors today, I'm quite certain that there are many, many more. The biggest risk with this exploit is, mainly phishing and brand defacement, using official domain names belonging to your organization. And there are many, many organizations that have a Chinese subsidiary or Chinese entity that are affected by these. Often even companies in Southeast Asia are using Chinese name servers to resolve their domains. So there's quite a broad impact here, but yeah, there are definitely more attack vectors to be found. Oh, there we go.
Cool. So we've gone through some of the, technical exploitation that we've sort of figured out in terms of potential attack vectors. But we wanted to take a little bit of a step back and, once we understood this, thinking about, okay, well, why is this happening and what can we do about it? This came about through, our development on our platform, and we were observing this in customers' attack surfaces. So this is, really the crux of, what do we do about this? So in terms of why this is happening, and we don't know specifics, right? This is all very black box. But, when you take a look at the keywords, most of them are related to, proxies, VPNs, adult sites, sharing, things like that. And these are all things that are aligned with things that are, China has been known to censor. So also, putting that together with the enormous efforts that we know that China does undertake in terms of, censoring the internet inside their country and preventing access to various sites, could this be part of that mechanism? And so we started to, try to develop some theories. And so the leading theory is really that this is related to censorship, with respect to the Great Wall, Firewall inside China, and it's manipulating the DNS responses due to sort of these blocked keywords or things that they want to blacklist and censor. This affects any system that has to pass through the Great Firewall before it reaches the end user and the client. And based on the keywords collected, as I said, and the limited information on how the censorship systems work in China, this is really sort of the leading theory for us. But there are still a number of questions that need to be answered at this point. Why are these subdomains appearing in passive DNS data sources, and why are the poisoned responses sinkholed to random blocks of IPs all over the world rather than just sinkholing it to some non-functional IP? So how did these end up in passive DNS data? So this pollution is present in several passive DNS data sources. This means that the client has to be resolving these in order for these to be logging in the passive DNS sources. The data is not logged for all domains, but we have noticed it on more high-profile domains and company properties. We suspect maybe other security researchers analyzing this issue and sort of brute forcing this stuff and trying to figure it out as a potential reason for this. But this one's the next question is more of an interesting one. It's like, why do the poison records not sinkhole to a non-functional IP, right? That would seem to be more effective with this. Why is it going to all this random IP space, which is actual stuff that's in use by other companies? And there's a great diversity in the networks that these poison records are pointing to. Stuff like large social media networks, cloud platforms, CDNs, even random blogs. And so our best guess is that these sinkholed IPs are not necessarily strategic. Like, it's not intentional that they're pointing to anything in anything specific. But given how many different networks are pointed to, and a lot of what appears in those results are organizations that would typically own large amounts of IP address space. So the idea is that it's probably pretty random, and it just happens that these organizations already own large blocks of IP space. But yeah, as I said, it's kind of weird. You'd think it'd be a little bit more effective to just sinkhole this and effectively block it if that's the idea. And so, is it possible that the filters are too greedy? So, suppose we wanted to block a specific domain, such as tracker.thepiratebay.org, right? But instead of just blocking that very specifically, maybe it's got some broader regex, imagining how this might be built. And that aligns with what we're seeing coming back from the poison DNS responses, right? That's why we're seeing, poisoning for non-existent domains, right? It's not necessarily, specific. So it is likely some sort of greedy filtering that's going on. It's most likely the reason for this poisoning on any domain with an authoritative name server hosted in China. And so, while we do kind of chuckle at the fact that some engineer may have designed this with, .star on both sides of the regex, in a way this does support our theory that this behavior is actually driven by censorship objectives. Essentially they're trying to block as widely as possible and avoid vectors which you can get around it. So, this is kind of an interesting thing. When we think about this as censorship, what's kind of interesting at the end of the day is the biggest risk are to the users that visit domains with name servers hosted in China, which is mostly going to be Chinese citizens, right? And Chinese companies and Chinese businesses that operate there. That's kind of an unfortunate sort of side effect of this. But since the poisoning is happening at least what we suspect is the Great Firewall level, there's not much that the users themselves can actually do to prevent these attack vectors that we've demonstrated today. And also the other side of it, as well as the list of keywords, we've got a bunch up, and we've got a bunch up on our blog from our research, but we could just be scratching the surface here. We don't know that we necessarily have the full corpus of what leads to this poisoning taking place, and presumably if it is censorship that's driving this, that could be changing all the time. We did explore some potentially wilder theories. We put our tinfoil hats on. What if this is not censorship? What if this is a way to facilitate a never-ending supply of rotating infrastructure to support CNC? As you guys may be aware, often, bad guys, malware developers use rotating domains to ensure that the CNC infrastructure is long-lived. And so in this case, with this technique, maybe China doesn't have to do that, where all the responses from these name servers hosted in China are being poisoned. We never actually worked out, the exact algorithm for how these DNS resolutions are routed. So we don't know 100% if it's deterministic, but, we're just sort of scratching the surface here, and I think we're just missing some knowledge. We're keen to explore it further, but, coming back to the real world a little bit and taking our tinfoil hats off, realistically though, this is not any kind of serious theory. It's most likely, based on everything that we've observed, that this is actually just part of the larger censorship infrastructure, of the Great Firewall. So what can we do about it, right? And unfortunately, this is not something that can be easily resolved, right? So there's a number of challenges when you're hosting in China, right? So you can't just simply, I don't know if anybody's tried this, but you can't simply just sign up to any kind of Chinese cloud or hosting provider, even like the Chinese versions of AWS or Azure and things like that. There is actually an extensive process that's required for hosting in China, regardless of which provider there is. And so if you wish to host within China or provide any sort of goods and services or have any kind of internet presence in China, you must apply for and obtain and hold a valid Chinese internet content provider license before anything can be hosted. So this was put in place a while ago, but basically every internet property, whether it's commercial in nature or not, must have an ICP license to operate in China. And in order to run a business and have any kind of internet presence, you have to have this first. And so there are a number of prerequisites and requirements that you need to get this license. The first is that you must have a domain name registered with a Chinese domain name registrar. You must have a server located inside China, and you must have a hosting provider that is licensed by the Chinese government. So you can't just, you just can't rock up and host stuff easily. And so, this kind of makes things a little bit interesting. So since this is a requirement of operating a business in China, it scopes in the DNS poisoning attacks that we've demonstrated to all companies that have an internet presence in China. And these requirements mean that even like we spoke about before, even companies like Cloudflare, they're kind of forced to follow these rules and host their name resolution infrastructure inside China, also making them susceptible to the DNS poisoning. And all Chinese communications have to go through the Great Firewall, including any kind of critical infrastructure such as NTP servers, DNS servers, things like that. And so we also need to stress as well that the rest of the world still can, and in some cases still has to communicate to this tainted infrastructure hosted in China. And so can you host name servers out of China, right? Like that seems to be like an obvious sort of potential solution to that. But there's also practical concerns with this, right? If you're looking at doing business in China, having an internet presence in China, you've got other considerations as well, not just the security, right? And so if you're hosting, say, name servers outside of China, even if you're allowed to do that, you might end up with speed and reliability concerns, and poor user experience for your customers inside China. And so, this just adds to sort of the limitations and challenges here. Most businesses will optimize for all of their Chinese web properties to be hosted as much as possible within China itself. This is through conversations with companies that do operate there. And it's not necessarily, just to stress the point, just due to these requirements and these regulations, but rather, so there's reliable access. So the other point as well to point out that it's not just it's not just like Chinese citizens and wholly owned Chinese business units that are at risk here. We've seen several very large organizations who choose authoritative name servers in China through cloud providers like Alibaba. This is particularly present in Southeast Asia in particular. And then, so this means in some cases, non-Chinese citizens are also adversely affected by these DNS poisoning attacks and can also be targeted. So this really comes down to now, like, how do we balance, this is sort of the overarching theme here, how do we balance the business objectives with the security objectives? China is a large and growing consumer market, and, it's often a very strategic business decision made at the highest levels to enter and operate in that market. And, generally speaking, those guys are not going to be swayed by security or technical considerations. And so, that gets tricky if you're sort of working at one of these organizations and you're thinking about how can I address this and mitigate this issue. Even really large companies, as we've shown, can't get around these strict requirements that go hand in hand with operating in China. So, let's be honest here. No company is going to walk away from a profitable market just because of concerns over security. We'd probably like that. Everybody in this room would, but we need to operate in the real world. So what can we do? What are some of the mitigations? So the obvious one that I mentioned earlier is, you can locate your name servers out of China, right? This is the most obvious and the best mitigation. But it may only apply in certain instances where you don't have to adhere to some of these rules, or maybe you can get around it. And as I mentioned earlier, there's also the downside that it could affect the speed and reliability of your services inside China. So it's not really necessarily a reasonable option, but it is the best option if that is possible. Because what we've determined is once your authoritative name server is hosted outside of China, the poisoning behavior no longer happens, and thus the clients will no longer be exploitable in the manners that we've demonstrated today. The other side, which is a little bit more in control, so less doom and gloom, web security hygiene. So specifically for the attacks that we've demonstrated today, they can be seriously limited if basic web security hygiene is followed. So things like enforcing the secure flag on cookies so they're not accessible by web servers that are not being communicated to via HTTPS. And additionally, enforcing HTTP only so that a simple XSS vulnerability cannot be escalated to still sensitive cookies. This is sort of like fodder that you see on pen test reports, but in this case, this can really limit the impact of some of these attacks that we've demonstrated today. That said, while that helps mitigate some of those attacks, brand defacement and phishing are still a real and exploitable risk in this case. And so, we've observed this internally at Acinode since about 2021, but realistically, it's probably been going on longer than that. Companies with a web presence in China, they, like I've said, don't really have too many options to mitigating the risk of this research. So, after we've sort of dealt with this internally for a bit and spoken to, our customers, who are also observing this, ultimately, maybe the best course of action at this stage is just to raise awareness of this, and get more eyes on it, and get other people thinking about this problem and what can be done about it. And that's really the purpose of this presentation. So we do have a lot more detail that we've hosted on our website. You can go to dnspoison.com. We've also included a little testing tool that you can use inside the post where you can put in a domain and see and confirm if it is, potentially vulnerable to this poisoning. And we just wanted to close out with some thanks to some folks who helped us with this research. So Eric, who shared the additional keywords and his own sort of research that he independently came to on this DNS poisoning. Sean Yo, who helped us with some of the data analysis of the returned poison addresses, and also our customers who we worked with, who contributed a number of valuable insights into the attack, but also specifically around the perspective of what we can do about it and the difficulties in mitigating the issue. And that's the end of it. Thanks, guys.
Any questions for Shabs and Michael? There's one up the back waving. Can you guys see? It's so hard to see people in this audience. Great talk.
Thanks.
Really good.
Yeah.
You wave again. There we go.
Oh, howdy. Firstly, that was an excellent talk. You have basically dove into something which is a problem I've had for a while doing a Mastodon instance. There is endless jobs which have basically failed because of bad resolution inside the .cn zones. So I'm definitely interested in kind of comparing my error logs inside my software with the whitelist, I guess the list that you've made, so thanks for that. And I'm going to try and see if I get any matches which aren't in your list, I'll send them your way. So, thanks.
I could barely hear that.
We could barely hear that on our side.
Hear that, sorry.
Yeah, well, okay, in that case, next.
Yeah.
Hi. I have an observation about the use of public in-use IP addresses. If they had just used sinkhole IP addresses or not used IP addresses, then there would have been a OSN leak of which domains they were interested in. So maybe they're using proper IP addresses that are routable because that provides less information about what they're doing.
Yeah, I mean that could be a potential theory as to why they're doing that instead of just sinkholing it. But then again, there's also the idea that generally speaking, China's usually not very subtle with what it does with respect to censorship and other things like that. So, but yeah, that's definitely an interesting theory. Yeah.
Being a runner running for questions is a great workout.
Are there possible mitigations through using, say, DNS over HTTPS?
I think this is still affecting, DNS over HTTPS is still affected. So if you try and use, let's say, Google's DNS over HTTPS, when it does reach to the authoritative name server, it's still going to be poisoned if that authoritative name server is hosted within China. So I don't think that resolves it necessarily. I think that, I think the only real resolution I've seen of this issue that I have seen successful is hosting your name server outside of China. So for example, if you try an attack on google.cn or facebook.cn, the reason it doesn't work there is because they're hosting their name servers outside of China. But that's the only real mitigation I've seen against this.
That's kind of foolproof, yeah.
Yeah.
Are there any other questions? Yep, one over on the left.
Hey, Dave. Have you tried testing what the behaviour is inside the firewall? So those IP addresses that are sinkholed, is it possible there's a second layer of maybe IP router poisoning happening, and there's a reason why it's social media and US companies or anything like that?
Yeah, that's a really good point. We haven't tried these attacks while being within China itself or Chinese infrastructure itself, but yeah, it could be going elsewhere. It's just from our experience so far, those list of networks, you're right, are really diverse in social media sites and data centers and Akamai, Linode, Fastly, all sorts of different. And that's really where we've been asking questions around why these networks in terms of what they're sinkholed to. But yeah, it could be different if you're within China.
Yeah. And we did explore that, but part of the reason that we haven't really gone ahead with that too much is for the reasons we outlined in the presentation of how difficult it is, more so how much of a pain in the ass it is to get anything up in China. We just couldn't be bothered after a certain point, basically.
So I want to ask if the website is hosted in, let's say, in Singapore, but it is operated by Alibaba Cloud. Will still this be affected or not?
It would be affected if the Alibaba name server is hosted in China.
Yeah.
Okay, thank you.
And that is something that we have observed with companies in Southeast Asia that are, for all intents and purposes, not Chinese companies, but they are using, say Alibaba and name servers hosted in China. They are affected by this.
Any other questions? I can't see any. Okay, another big round of applause for Shubs and Michael.
Thanks, guys.